Hi everyone, thank you so much for joining my session about Terraform practices. So Terraform is a great tool, right? It is used widely across the world. And this talk will cover not only specific bits and pieces regarding Terraform usage and practices, to enable infrastructure scaling and much more, but also hopefully will make you think about your unique use cases and scenarios and help you see the big picture and utilize Terraform in a broader context rather than just an infrastructure as code tool. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I have recently joined the AWS Community Builders Program. In Israel, where I live, I help co-organize DevOps conferences and events like DevOps Days TLV conference and StatsCraft Monitoring Conference. I'm a mentor in courses and communities in Israel for open source in Israel and elevating technical women in tech. And I think that DevOps culture is very, very important to achieve great things when it comes to a company setting. And I am a lead singer in a cover band, as you can see in this picture, and I think and I feel it's a lot of fun. Okay, so Terraform implementations can be good, sometimes can be bad, and sometimes can be really, really ugly. And some disclaimers about this talk. I only use Terraform open source, not cloud or enterprise. So every example that I will show here or implementation is about the open source. So probably in Terraform Cloud or Enterprise, it is being implemented differently. So just bear that in mind. And I'm mostly showing examples from AWS cloud provider here, but of course, Terraform works perfectly with all cloud providers. So just bear that in mind. Okay, so quick wins. When I say quick wins, I mean things that you can do in a matter of minutes to achieve great usage of Terraform. Basically, low effort, high value things that will help you scale better and more efficiently and prevent even refactoring and extra work later on. So first of all, versions lock. The same as you can lock versions in requirements.txt for Python or packages JSON lock, right? So the same goes for Terraform. You can lock modules, providers, and Terraform versions, as you can see in these examples. And the thing about locking provider versions, as you can see in this meme, is that sometimes there are issues with the Terraform providers, and we want to deal with the devil that we know, right? If we know the issues, we know how to handle them. And if we don't know, then we will have a lot of unexpected stuff going on. So let's deal with the devil that we know and lock the provider versions. So the good thing is to lock modules, providers, and Terraform versions. The bad thing is to lock in a way that will still allow breaking changes to occur, because if we lock to a minor version and not a major version, then maybe breaking changes are still there and they will happen. So try to always lock to major versions. And the ugly thing is really to have no versions lock whatsoever. You will have syntax issues, you will face some stuff, so try to avoid that. And the thing is about consistent versions and no conflicts or breaking changes is that it will help your teams in the long run, right? Because then you don't waste time on these kind of things and you can keep on delivering projects and stuff. So that's about versions locks. The next thing that I want to cover here is tagging resources. So for me, it's a must implement practice because it allows you to filter your cloud provider expenses and sort them by tags to distinguish between resources, and also other tools like Datadog, for example. It allows you to have cost control and it is done through tags. So this is another reason why tags is so important. Also with tags, you gain visibility and ownership on ownership and overall projects by tagging according to a logical breakdown that you see fit. So that's why I hope that I convinced you the tagging is so important. And believe me, if you tag your resources, your FinOps team will be happy. And if you don't have a FinOps team in your company, congratulations, you are the FinOps team. So just bear that in mind that it really, really helps with cost management and a lot of other cool stuff. So for example, we use these tags in Wix to tag our resources. And as you can see on the right, you can use default tags in the AWS provider, and it means that every resource that you will create will automatically get these tags. So this is very, very important because it will save you time. You just set it up once and forget about it. So the good thing is to tag everything that you can. Use default tags whenever it makes sense. For example, for the managed by Terraform, it totally makes sense. And if you have other resources tags that should be on all tags, then you should define them for default tags as well. You should do PR enforcement, which is something that I'm gonna cover a little bit later on, which means that you set up tests through your CI or through GitHub Actions or something like that, that if someone didn't add tags to the resources that they're going to create, then the PR merge will fail. And I'm gonna cover it in a bit. The bad thing is to tag inconsistently because, as we know, consistency is key and it will help you do automations even if you need to. So try to be as consistent as possible. And the ugly thing is to have no tagging whatsoever. Really, it will be very hard to track costs, to track which resources belongs to which project and team. So try to avoid that. And the next thing and the last thing in the quick win section is having a remote state. So by default, Terraform works with local state, and remote state helps you to scale your team because everything is remote and you have one source of truth. So in this example, again, AWS, you can save your state in S3 bucket, and that's that. So the good thing is to have your state remote and backed up. You should always, and secured, of course. And as for backup, you should use like S3 versioning if you keep your state in S3. And make sure that you have a Terraform state lock. You can use DynamoDB for that, which means that when you run Terraform apply, the state is getting locked and nobody can run in parallel, and then you wouldn't have any conflicts. And the bad and the ugly is basically the opposite. So local state, if the state is remote but not secured or backed up, and if you don't make sure that the state doesn't get locked when you run a Terraform apply. Okay, so these ones were quick wins, stuff that you can achieve in a matter of minutes that will help you in the long run and use Terraform in the best way possible. Let's talk about second nature. And when I talk about second nature, I mean day-to-day awareness that will help you reduce refactoring code in the long run, prevent time waste, and align to best practices, and basically stuff that you will have to have with you day-to-day when you work with Terraform. So let's see. First of all, using community modules versus creating them yourself. So there's a saying, right? Why reinvent the wheel? It's exactly that. A lot of well-known cloud provider features are already covered by modules. So do your research and check available modules before implementing yours. And the thing about using community modules is that really it's good because they are proven over time, they are supported by the community, and you eliminate the need to support it and keep it up to date because they do it for you. So that's awesome. And also what I mentioned before, practices enforcement, they are set up in a lot of community models as well. So they want to make sure that people only commit a high quality code and things are being checked out, certain things. So they are implemented in a lot of community models that I have seen. So it's good because then you know that the code is in a high quality state. So the good thing is to use verified community models wherever possible. And when I say verified, I mean that up until recently, there are all models were in the Terraform registry, but then the verified label got removed. So just make sure you download and use modules that have a lot of downloads. Then you know that a lot of people are using it, and that's good. The bad thing is to have a custom module of your own, but if you still maintain it as a community model, aka you have checks in place and you have the practices enforcement and so on, then it's still okay. And to use community model without a version lock, then this could be an issue as well, as I explained in the other section. And the other thing is to have a custom model and not maintain it. You will lose track of what's going on and the ability to enhance it, and that's not good. And to use unverified community models, it's not good as well, because it could lead to a malicious configuration being introduced to your environment. So you don't want that. And if you do have to create your own models, then make sure you make them stateless and clean, aka generic, and you do not repeat yourself if you don't have to, and the code is kept as simple as possible, and enforcements are being set up to maintain quality. And of course, I know that I build up for the practices enforcement quite a lot, but trust me, it's worth it, so stay with it. Okay, the next section I want to cover is variables versus locals. So unlike variable values, local values can use dynamic expressions and resource arguments. And also locals also don't change values between Terraform runs, like plan, apply, and destroy. And you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. So you can see this example right here. I've set up different variables, project and environment, and then I use them as required tags, and added another tags along with it and merge it. So the merge is the final result of the tag and the local tags, and then I use that throughout my configuration, and it's always set up like that. So this is one example. Of course, you can do a lot of complex things using locals. So on how to use them, on the module side, for variables, you should use them for like settings for the module configuration, but make sure you set up a default or validation, because if not, then people that will use the module and don't pass values to these variables, then the module will get break. So this is an example for a validation that you can set up. And on the module side still and locals, you should consider it as a constant to be honored or relied on. So let's say, for example, I create a module to have S3 buckets creation, right? So, and I want naming convention. I can set it up on local to have a naming convention for the bucket, and then everyone that uses this module will be bound to this naming convention. That way we have order in our department or even in our company, and we can really track which buckets are ours. But in specific to this example specifically, when you think about naming convention, just think about the limitations of your cloud. So if there are characters, limits, etc., then it's something to be considered here as well. So I talked about the module side. On the live side, and when I say live, I mean where we call the modules, right? Because module is like a class in code, and then the live side is the instantiation of the class. So on the live side, for variables, if you use them once, just set a default, and if you use them per region, etc., just use a tfvars file per environment or region. And as for locals, you should really avoid using locals, because we want to keep the live side as simple as possible and leave the logic to the module side. And you should use data sources to pass outputs to the module, because that way we have dynamic configuration and up-to-date values that being passed to the module, which is always great, because we always want to have the most up-to-date data to use. So the good thing is to use tfvars whenever necessary. Utilize environment variables if you have them, because that way it will eliminate extra variables, because you have like a built-in variables to use already. Use locals to dehard code one-time names and decrease code repeatability, and just have like a general notion of keeping things generic as much as possible. The bad thing is to use multiple locals blocks if not necessary. It's something that Terraform allows you to do, but if you don't need to, why use multiple blocks? It will be harder on your eyes and to maintain, and maybe people will put it in different files, and it will be hard to keep track. So don't do it if you don't really have to. Decentralized vars, so you should use, and I will talk about file structure in a bit, but just use one variable files and put everything there instead of spreading them out, because again, we want to have the ability to maintain it in the best way possible. And ignoring environment variables, because then you will need to create extra variables. And the ugly thing, is hard-coded variable values were not necessary, because that's exactly it. Variables, they need to vary. So just make sure that you don't hard-code values where you don't need to do it. The next section is file structure, as I mentioned a bit ago. So we should have a file structure that makes sense for better logical arrangement and easy management. And as we know, Terraform just executes all files that have the file extension of TF. But for us to have the better arrangement and management of the code, we should structure the files in a way that makes sense. And let's take example from the community again. So community standard looks something like that. We have main TF for the main logic of the module, and then variables, data, and outputs. But sometimes outputs is not there, and then people use instead or in addition versions for the Terraform versions. So it's also something that I recommend to add. And it's best to have this kind of naming convention which reflects the actual purpose of each file. And that way you will get a decent logical arrangement for faster access, better readability, and cleanliness of the code. So if, for example, you have the main logic, let's say for a module that creates a VM, then the creation of the VM will be in main TF. But then if I have peripheral stuff like load balancer or security groups, I will put them in separate files that suggest their meaning, and then it will be helpful for my logical arrangement and better management. And also, if you create a complex module, then consider breaking them down to submodules, because that way you can both reuse parts, like independent parts of that module, and also you can you don't have to have like a very big variables file, because it will be hard to understand which variables belong to which part, and you just break it down, and each section, aka submodule, has its own variables file. So that's good to have, and we also have example about that from the community as well. So the VPC module has a VPC endpoint submodule, and then the EKS module has a submodule of creation of the node pools. So that's about that. Okay, the next section that I want to cover here, I really like it, and some people will maybe raise eyebrows and like, what? Classic code best practices on Terraform, but Terraform is not really a pure programming language, right? So don't worry, I don't think that Terraform is a pure programming language. I don't think that anyone thinks like that, but still similar rules of writing code apply to Terraform as well. Terraform progressed over the years in a way that adapts code best practices. For example, you might remember that before Terraform 0.13, you can't even use for each for modules. And with the release of Terraform 0.13, HashiCorp finally introduced the ability to loop over modules with a single module call. So this section that I just told you here, and another thing that I'm gonna say in a bit, was mentioned in a great article by Tizian Uo. He's great, and his blog post is very good about Terraform, so I will post about it. I'll have a reference slide at the end, and you will be able to see that and read this article. So let's apply classic code best practices on Terraform. So keep the Terraform code on in a source control management. Keep the code as simple as possible. Do not repeat yourself if you don't really need to. Even functional programming principles can be applied on Terraform as well, and keep the code idempotent. And in regards to human and clean, I want to quote something else from Tizian Uo article. He said, and I really couldn't say it better, that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate, right? If used correctly, it still gets executed. But since human beings are the ones to maintain the code, we need to make sure it is readable, right? Things like refactoring and clean code and naming convention and stuff like that are invented so that we humans can read the code better. for the sake of us humans and not the computers. So please try to stick to that and apply classic code best practices as much as possible, also when you're dealing with Terraform. So we talked about quick wins, right? Things that you can achieve in a matter of minutes, like low effort, high value kind of things. We talked about second nature, things that you should keep in mind on your day-to-day basis when you work with Terraform. Let's talk about the long haul. So on a company, right, on your job, you will have collaboration and you will need to add more resources, and different teams maybe need to work on the same infrastructure or doing audits on that infrastructure. So you should really consider these long haul practices to allow them to have the needed visibility on that infrastructure, and also maybe to isolate environments, right? Because we all have dev and production, and we need to isolate these environments and their changes or effects, and basically just scale Terraform usage by teams and the infrastructure itself more easily and more efficiently. So let's cover some very important practices in regards to that. But beforehand, I want to ask you a question. How do you envision the infrastructure and the company's needs? Because when we work with Terraform, but when we work with any other tool or any other technology, we really need to think things through and do what's best for the company's needs and infrastructure use cases. And I want to tell you a little story about that. So in one of my daily syncs at work, I'm working for the data engineering group, and we support tools that help them query data like Presto. And currently we have Presto installed on a fleet of machines like Autoscaling Group for VMs. And on the daily sync, it was raised an idea to move Presto to Kubernetes. So all my team members was like, yeah, let's move to Kubernetes. Yes, let's do it right now. Let's move, let's open a ticket, move it, stuff like that. And in my, between me and myself, I thought to myself, yeah, I also want to move to Kubernetes because, a lot of companies adopt Kubernetes, and it will, even though I do have already Kubernetes experience for my previous company, but, with Kubernetes, there is no enough experience. Kubernetes is very, very complex, so there's not enough, and you could always learn a lot. So I said to myself, yeah, I want to move to Kubernetes as well because it will be helpful for my career, right? If I know more and more stuff and more use cases and more hands-on on Kubernetes, then in any other company that I would like to work that has Kubernetes, it will help me there. But then I stopped myself because, it was all in my head at that moment. And I verbally and vocally said to my team members, I said, wait, we need to think about it and see that even Presto can work perfectly on Kubernetes, that there are already use cases about that Presto, whoever created Presto, said that they support Kubernetes, right? So we need to make sure the application can run as we want it to run, and not just because we want to run it and because of buzzwords or any other thing or reasons we have to do things. So I hope that this example showed you that we need to think about the company's needs, we need to think about infrastructure needs and not what we want, at least not in a work setting. So let's talk about the long haul practices. Since we planned things ahead in weeks, we thought things through. Hence, we decided to use Terraform and structure the code base in a way that will make sense to us, because we believe that this structure is helpful, and I will show you why in the long run we made the right choice. So about structure of Terraform code base, this is how we do it in weeks. We structure it with at the beginning of a team, and then project, cloud provider, and region. This is an example. So we have live and modules, right? And then BI for team, Airflow for project, AWS for cloud provider, and then US East 1 for region. And why did we choose this structure? Two main reasons. First of all, Terraform is a platform, right? Every team that wants to use Terraform is being onboarded to the same repository that you see here. It's one repository for all teams in the company, and then all teams can use the same modules that are already there. They have complete autonomy on the root tree folder because it's per team. So we use code owners in GitHub to select which teams or groups in GitHub are allowed to approve their own PRs. So they have a complete autonomy about their code, and just every team that wants to use it onboarded to this repository, and immediately they get out of the box modules that we currently have. And of course, the practices enforcement that I mentioned before, and I will mention in a bit, about stuff to make sure, checks that are set up to make sure that the code is in a high quality state. And we all want a high quality state because it means that it will be easy to maintain in the long run, and that that the code is good to use. So this is one reason why we chose this structure. Another reason to choose this structure was the thought about Terraform states. So I hope that you know Terraform creates a dependency tree in the code, meaning that it knows when to run stuff. So if I created a VM and a security group, it of course, I don't need to put depends on, it will create the VM first, and then it will create the security group and link between them. And the thing about Terraform is that it doesn't always create the valid dependency tree, right? It sometimes creates invalid dependencies, and then you just change a tag, and then when you run Terraform plan, you see it's going to destroy a resource, and you're like, why? I only changed the tag, right? So that's the thing. Since Terraform sometimes do invalid dependencies, we need to help Terraform do its job. So we need to keep the Terraform state as small as possible to eliminate a big blast radius. And because of that, this structure helps perfectly, because in this structure, the state file is only kept on the US East 1 level, which means that it's state only for Airflow resources for the BI team in US East 1 region for AWS. That's it. So it's very, very important to structure the code base in a way that will prevent a big blast radius and just keep it as small as possible because of the dependency issues that I explained a bit ago. So that's the reason why we chose this structure. I want to also cover stuff about workspaces in, again, open source, because it's a bit implemented differently in Terraform Cloud. So workspaces isolate their state. So if you run Terraform plan, Terraform will not see any existing state of any other workspaces, only that specific workspace. And when should we use it? When we have same Terraform config for different customers. So let's say let's take an example for GCP. So I have different GCP projects. Each project is a customer, but it's the same Terraform config because all projects are basically the same from code-wise. So each project will have a workspace of its own. Coupled with that, let's say we have a lot of customers, a lot of projects, but all of them need to use the same service in different regions, right? Like the same financial service or the same login service, right? So these kind of services can be also kept in their own workspaces as well. Some notes about workspaces, though, is that you should really consider using Terraform wrapper when you use the workspaces to avoid human errors. Because how do you use workspaces with CLI Terraform workspace select X? If I forgot to do this select, production incident. Okay, so just try to avoid that and have some sort of a Terraform wrapper. You can create like a mini system with Python, for example, to run the selection and the switching between workspaces for you. Another thing is that you have less visibility. So unless you use the Terraform workspace built-in variable, you don't even know that you have workspaces. And even if you don't use this variable and you doing the CLI Terraform workspace list, and you see a lot of workspaces, you don't know that they are actually in use. Maybe someone created that and that's it, and forgot about it and just did it for tests and stuff. So just bear that in mind, that you have less visibility with workspaces. So if you do choose to go down this path, really plan ahead and do the Terraform wrapper and do it in a way that wouldn't cause you headaches in the long run. Another thing about workspaces is I want to quote something from the Terraform documentation. They write that use workspaces to manage multiple non-overlapping groups of resources with the same configuration. So like I said before, it suggests that these usages are qualified, right? Multiple environments for dev, staging, production, multiple regions or locations, or multiple accounts or subscriptions. So far, so good. But also from the another section of the documentation, they say that multiple deployments of the same infrastructure serving different development stages, staging or dev production, named workspaces are not suitable isolation mechanism for this scenario. So I don't know, in my entire career, I haven't ever had the same infrastructure serving both dev and production. I'm not sure if this is what they meant or something else, but if this is something that raised a question for me, maybe it will raise a question for you as well. So just bear that in mind and have that also as something to consider when you going to work with workspaces. And at least we can all agree on one useful workspace usage, a classic one, like a side branch. So you can create a workspace, test your syntax there, test your infrastructure changes, see how it goes. And if all looks good, then you apply these changes on the default workspace, which is production. So in regards to structuring your Terraform codebase, the good thing about planning ahead and really think things through when you think about structuring is that it will help you to set up small state files and set up Terraform as a platform, and then everyone can enjoy Terraform and use it to its best ability with all the things it allows you to do. The bad thing is that sometimes organizational changes will require you to restructure the code, and we don't want that. We want to have a control and restructure code only because of reasons that are under control, right? So it's something also to consider. And using workspaces usage using workspaces for the wrong reasons could also be problematic. And the ugly thing here is to have a structure of code base that will allow huge state files, because again, it will allow invalid dependencies to occur much and more frequent, and then you'll have a very big blast radius, and you don't want that. Let's talk about Terraform execution. So remote execution is very, very good because it will mean that you don't need to set up local credentials, you don't need local configurations, and you have audit. If someone did something, then if it's local, you don't see and you don't know that he or she or they ran it. So Terraform execution, if you set it up to be remote execution, that is great. Also for Terraform, for Teams scaling, because everyone can run it remote, and that's that. You should run Terraform apply with a plan file, and that way you know exactly what you're applying, and set up a Terraform timeout that makes sense to you, because on one of my previous tasks, I had to create an auto-scaling group with spot instances, and the price wasn't right. I selected a too low price, and then I had to wait and wait until Terraform reached timeout to say that it couldn't create the auto-scaling group machines already. So just make sure that you have Terraform set up to set up a Terraform timeout that makes sense to you. The bad thing is to execute locally, because again, you'll need local credentials, local configurations, and no audits on what you're gonna do, which is not great. And the ugly thing is to execute locally and run Ctrl+C when you run Terraform apply. I did it when I just started out with Terraform, and it messed up my state. I don't know if this was fixed by now or not, but trust me, I don't want to find out. So try to avoid doing any Ctrl+C when you run a Terraform. If you do have to run locally, don't do Ctrl+C, just rely on the Terraform timeout that you set up. Practices enforcement. I know that I talked about it quite a lot during this presentation. We finally got to this point. I think this is very, very important thing to do. And it's something that, as I mentioned before, models, community models follow and set up these practices to make sure that best practices are set and to make sure that we have a readable code and cleanliness of the code. And in order to keep all of that in check, we need to use enforcers, right? So if I want to check if the code is readable and if the resources are tagged, if the code is reusable and clean, and a lot of other things and other guidelines as well. If you want to set up anything, like when someone creates resources that cost more than $10,000, let's alert FinOps team, for example. You can set up anything that you want, and you can do it with a practices enforcement. And I'm going to show an example from a community module. So this is a community model, the Terraform AWS auto-scaling one. And as you can see, there are checks there to make sure if the contributor formatted the code using Terraform FMT, if the contributor added documentation, and if it's a working code, right? TFLint, to make sure the code is actually working and the syntax is correct and all. So that's awesome, because in this way we can have a quality code passed in the PR, and if not, the PR will get failed to merge until the checks will pass. So this is an awesome practice. I really encourage you to do it. And again, you can put any guidelines and best practices for your specific company as well, and set it up as these checks. So the good thing is to have pre-merge linters, formatters, and logical checks set up. You can do it with GitHub Actions like we do it in Wix, or in CI pipeline checks. You can use a Slack bot to detect any drifts, or you can do what we do at Wix, that is it makes that bot redundant. We have Atlantis integrated. Atlantis is an open source tool for Terraform pull request automation. So when I open a PR, automatically in the background it runs Atlantis, and Atlantis runs the Terraform plan. I check the plan, I see that everything looks good, and then I write in the GitHub comment, in the GitHub PR comment, I write Atlantis apply. Once I do that, two things happen. First of all, the code gets merged to main, right? And then it also gets applied on the actual environment. This allows us to really keep in check the fact that the main branch equals to the state of the actual environment. And then we don't need any Slackbot drift reporter or detector, because since we all run only remotely and we use Atlantis, then it just do this verification for us. The bad and the ugly thing is not about practice enforcement. It's actually about, if you don't set up practices enforcement, then you could face security issues, and a non-compliant configuration can be introduced to your code without you even know that. So try always to avoid that, and use practices enforcement. And to help you with the practices enforcement journey, here are some open source enforcement and helpers that you can incorporate in your journey, and they will be really helpful for any or a lot of use cases that are already needed when we work with Terraform. Okay, so I asked you this question before, right? I want to ask you again. How do you envision the infrastructure and companies' needs, right? So if you think about the infrastructure and companies' needs, then you will be able to set up guidelines and best practices of your own, like tagging usage and stuff like that, and restructuring models and Terraform utilization by others. So you can do a lot of things if you just plan ahead and do what's best for infrastructure and your company's needs. So please try always to think about these kind of needs. And the main things that I want you to take out of this presentation are these two things. I really hope that it's not big enough, but if it's not big enough, I will make it even bigger next time, because this is very, very important. So code-based structure, Terraform is a platform, right? It's really helpful for team scaling and also infrastructure scaling in the long run, and to have small states files set up. And practice enforcement, it really helps you to enable infrastructure scaling, team scaling, and to set up any guidelines that you can think of for your company and for your department in specific. And I want to say another thing and quote another thing actually from the TCN blog. Is really great. You will have a reference slide right up. He said that programs evolve and code changes, right? And it's uncommon that you write Terraform code and it stays the same, right? That's not how projects work. If it was the case, we wouldn't be even talking about Terraform practices. All of us will just use it the same way, write the code, continue with our lives. But we will always have projects because businesses want to improve, and changing from the current state to the next desired state is a project. So think about how you structure Terraform code base and treat Terraform generally. That way you will allow projects to evolve and get introduced and help your company improve and contribute to the company's success, and of course enable infrastructure scaling and your team scaling as well. These are the references that I used throughout this presentation. I hope that it will be beneficial for you as well. And that's it. Thank you. I really hope that you enjoyed this presentation, and it will be helpful for you for your day-to-day with Terraform. And if you have any questions, here are my contact details. You can reach out and I'll be more than happy to help. Thank you so much.